We are going to graph linear functions. That's our focus. Our two learning targets are we're going to graph a linear function in slope-intercept form, so that's at y equals mx plus b, and then we're going to graph a linear function in standard form, and that's at ax plus by equals c. So we're going to go through each one of those forms. So let's start off here with slope-intercept form. The slope here being your m value, which is right here. It's right next to the x. That is your slope. That's your rise over your run. And then we have the y-intercept here, which is the b value here. That is your y-intercept. And that's where it hits the y-axis. So whatever your y-intercept there is, that's where it's going to intersect there at the y-axis. So our first example here is we're going to graph this linear function, and it's going to be in slope-intercept form. It's in y equals mx plus b form. Remember, we've been talking about functions, so we rewrote this f of x here, and that's the same thing as your y. So f of x equals 3x minus 1. So if you remember your form, it's y equals mx plus b. So our slope here, or our m value here, is 3. And that is 3. If there's not a number at the bottom, it's a 1. So we're going to do rise over run. But where do we start? We start at the y-intercept. And where is the y-intercept? The y-intercept here is this b value, which is this -1. So that's our y-intercept. So let's come over here and let's plot our y-intercept. And from the y-intercept there, we are going to rise 3, so just count up 3, 1, 2, 3, and run 1. If it's a positive 1, you want to go to the right. So then 3, a positive 3, you rise 3, 1, 2, 3, and then you run 1 to the right. 1, 2, 3, and you run 1 to the right. And then I can simply connect my points there as straight as I can make it. So there it is. Our next example here is also a linear function, and it's in y equals mx plus b form. So I'm just going to change this f of x to y equals. So where am I going to start? I'm going to start there at my y-intercept, and my y-intercept there is at 3. So on the y-axis here, I'm going to go up to 3 and put a dot. And then what do I do next? So first here, I plotted my y-intercept, and the second thing I'm going to do here is work here with my slope. And my slope here is my rise over my run, so it's a -2 over 1. So from that point there, I'm going to come down 2, and then it's a positive 1, so I'm going to run 1 to the right. I'm going to come down 2 and run 1 to the right. Going to come down 2, run 1 to the right. Come down 2, run 1 to the right. Down 2, run 1 to the right. You only need 2 points minimally. I just like to make it look like a nice line, so I just keep it going with the slope. So this time we have a fraction for the slope, but again, let's start with the y-intercept. It's still in this y equals mx plus b, and that b value is 4. And that equals my y-intercept. So let's plot the y-intercept up there at 4. And then my slope is the m value, which is that value right there, which is the -1/2. Now I like to put the negative up. If you want to put the negative down, you can. You just can't put it up and down. So this is my rise over my run. So I'm going to come down 1, and since it's a positive 2, I'm going to run to the right. If I come down 1, I can run to the right. Come down 1, run to the right. Now, if I would have done it the other way, like kept the positive 1 up, then I could have put the -2 down. So then I would have risen 1 and then run 2 to the left since it's negative. Risen 1, run to the left. So then as soon as I want to, I can connect my points. And there it is, a nice line. This one here is also a linear function. Notice it doesn't have an x value in there. There's not an x term in there, so I could put it in there. I can just put 0x and then minus 6 if that's helpful. So that would mean my y-intercept here is my negative 6. So I'm going to plot my negative 6. And then our slope here is just 0 over 1. So again, your rise over your run. So at my negative 6 here, I'm not going to rise at all because it's 0, but I'm going to run 1. Then I'm just going to keep running 1, running 1, running 1, running 1. And then I can just connect my points. And I just have a nice horizontal line. Some people like to do a little t-table, so you could do that instead as well. It says y has to equal negative 6. And then you could just choose some values and plot them if you wanted to. So that's another way of being able to plot that out. So you could pause the video and go through the your turn problems here and then start it up together and start it up again, and then I'll go through those for you. All right, so we have these last two functions here to graph out, these linear functions here. Letter E here, it doesn't have a y-intercept, so I'm going to put a plus 0 there. So my y-intercept is right here at 0. And then my slope is at 4/3. So I'm going to rise 4 and run 3. Rise 4, run 3. And connect my points. All right, so likewise with this one here, my y-intercept there, again, that 8 there is my y-intercept. So I'm going to come up here to 8 and plot that. The negative there, I'm going to put it up and the 5 down. So this is my rise over my run. And I'm going to come down 4, 1, 2, 3, 4, and then run 5 to the right. Come down 4, run 5 to the right. Connect my points, and there we have it. So the ones there on the 1-4A worksheet there has to do with graphing in slope-intercept form. We're also going to go through graphing linear functions in standard form. So those there is in standard form, remember it's an ax plus by equals c. So the easiest way probably to do that is just to go ahead and rewrite in y equals mx plus b form. So that's what most people like to do that as. So that's what we're going to do. So this one here is in standard form, so it's not in y equals mx plus b form. So let's rewrite it so that it is. So I'm going to bring my x over on this side. So I get negative y equals negative x plus 6. I have to get rid of this negative 1, so I can divide every single term in here by negative 1, and I get y equals x minus 6. So again, this is my y-intercept, and my slope here is 1 over 1. So let's plot our y-intercept. So down here at negative 6, and then I'm going to rise 1, run 1 to the right. Rise 1, run 1 to the right. And I'm just going to keep doing that, and then connect them. So remember standard form ax plus by equals c. So there we have it, 2x minus 5y equals 10. So what are we going to do? We're going to go ahead and get rid of the 2x. So I'm going to subtract 2x from both sides. We get negative 5y equals negative 2x plus 10. I'm going to get rid of the negative 5 in front of the y, so I'm going to divide every single term in here by negative 5. And we end up getting y equals 2/5 x minus 2. because in both those cases, a negative divided by a negative there are positive for those first two ones, and then the last one there, 10 divided by negative 5, there is a negative 2. So again, let's plot this out. This is my y-intercept, so that's where we start. So we start there at negative 2, and then we're going to use our slope here next. That's the second part. So we're going to rise 2, 1, 2, and run 5. And the other one's not going to fit on there, so I'm just going to do the 2 points. So likewise on this one here, it's in standard form. I'm going to leave my y on this side, so I'm going to bring my x over on the other side, so I have to subtract x. The negative follows with the 3y because it's in front of it, so negative 3y equals negative x plus 4. I have to eliminate the negative 3 next to the y there, so I have to do the opposite of their multiplying there together, so I have to divide every single term in here by negative 3. So y equals, remember this is like a 1 there in front, a negative divided by negative there is a positive, so we get 1/3 x, and then a positive divided by negative there is a negative, so I get a negative minus a fourth, negative 4/3, or minus 4/3. So then this is my y-intercept. So this time it's not a nice integer there, it's a, we've got a fraction there, so let's graph out negative 4/3. So you could do it on your calculator if you're not sure what it is. You could do negative 4 divided by 3, and it will tell you that it's a negative 1.3 repeating. So where would that be? Well, it'd be a negative 1 and 1/3 of the distance between that and negative 2. So it's about right there. And then from that, I'm supposed to go ahead and use my slope there. So I'm supposed to rise 1. So maybe I'll make little tick marks of where I'm putting those. It's a little bit harder to do it up here, but I'll try to do that. So I'm going to rise 1, which is about right there, and then I'm going to run 3. So 1, 2, 3. I'm going to put my dot. Then I'm going to do the same thing again. I'm going to rise 1, which would be about right there, and then I'm going to run 3. 1, 2, 3. So next one here, we've got x equals 7. This one here is not in y equals, so we might want to do what we kind of started with that other one, where we had a y equals. We had a y equals just a constant term. This time we have an x equals a constant term. So they told us that x equals 7, and we don't have a y value in there at all. We don't have a y term. So we're going to go ahead and just put 7s in for x's because that's what it says. X has to equal 7. And then for y's, we can just pick whatever we want. So let's plot those ordered pairs out. 7, 0, 7, 1, and 7, 2. And then I can just connect those. So this one here is not a linear function. It's just a line. It makes a line here, but it's not considered a function. But it's still linear. It's a linear equation here, and we just graphed it out. So I should just say graph. There. We'll just call that a line. So we have 2 of them over here for you to graph. So again, if you want to pause the video and then try them out yourself, and then go ahead and play it again, and I'll go through them. All right, so we're back. Again, let's put this in y equals mx plus b form. So I'm going to go ahead and subtract negative 3x from both sides. We get negative 4y equals negative 3x plus 12. Get rid of the negative 4, so I'm going to divide every term in here by negative 4. And we get y equals a negative divided by a negative. There's a positive, so it's 3/4 x. A positive divided by a negative is a negative, so I get a minus 3. So again, my y-intercept there is negative 3, so I'm going to plot that. and then I've got 3, 4. So I'm going to rise 3 and run 4. Rise 3 and run 4. And then I'm going to connect my points. This one over here, because I don't have a y at all in this, I'm just going to go ahead and do a little t-table here. It says that x here has to equal -3. And then since I don't have a y term in here, I can pick whatever y values I want and plot it out. So -3, 0, -3, 1, -3, 2. And so I can see it's making a nice vertical line. Again, that letter F is not a function. It's just a linear, we graphed out the linear equation and got a line. So now you're going to work on the 1,4b worksheet.